There's a place beyond the planets where the sun becomes only another distant star. Voyager 1 is there now, moving through darkness no human instrument had ever entered before. Scientists expected emptiness. Instead, the spacecraft found invisible waves, changing densities, energetic particles, and a persistent signal running through interstellar plasma, like a heartbeat beneath the silence. The discovery was already difficult to explain. Then Voyager revealed something even more unsettling. The barrier surrounding our solar system is not completely sealed, and the galaxy beyond it is still interacting with the space we call home. Voyager 1 was designed to survive for only a few years. Now, in 2026, it may be the only machine capable of telling us what truly exists outside the sun's protection. The sun is constantly releasing charged particles into space. This flow, known as the solar wind, expands outward beyond the planets and creates an enormous bubble called the heliosphere. Every world in the solar system exists inside it. Earth, Mars, Jupiter, Saturn, and even the distant Kuiper belt all travel within an environment shaped by the sun. For decades, scientists believed the outer edge of this bubble would mark a relatively simple transition. The solar wind would weaken, interstellar particles would become dominant, and the spacecraft crossing the boundary would pass from one predictable environment into another. Voyager 1 reached that frontier in August 2012. Its instruments recorded a sharp decrease in particles coming from the sun and a dramatic rise in cosmic rays arriving from the galaxy. The spacecraft had crossed the heliopause. Humanity had placed a functioning machine beyond the sun's protective bubble for the first time. But Voyager did not enter the calm interstellar space scientists had described. It entered a region filled with disturbances, pressure changes, and invisible structures that theoretical models had never been able to see. The boundary was not the end of the mystery. It was where the mystery began. In 2017, Voyager's plasma wave instrument detected a faint emission surrounding the spacecraft. At first, it seemed almost too subtle to matter, but the signal did not disappear. It continued as Voyager traveled hundreds of millions of miles farther into interstellar space. The emission allowed scientists to estimate the density of the plasma around the spacecraft almost continuously. Before this, researchers could only measure interstellar density during occasional disturbances caused by powerful solar eruptions. Those measurements provided isolated moments. Voyager was now revealing an evolving landscape. The density changed along its path, rising and falling as the spacecraft crossed different regions. This suggested that interstellar space contained layers, waves, and enormous structures made from charged particles and magnetic fields. In other words, the space between stars appeared to have something resembling weather, not clouds, rain, or wind in the terrestrial sense, but variations in pressure, density, and energy moving through the galaxy. Scientists still do not know exactly what produces the persistent signal. It may come from natural oscillations inside the plasma, or it may represent a more complex mechanism that existing theories do not fully describe. Voyager found the pattern, but understanding it may require measurements the spacecraft does not have enough time left to complete. The heliopause was supposed to separate two distinct magnetic environments. Inside it, the sun's magnetic field dominated. Outside it, the galactic magnetic field should have taken control. Voyager discovered that the transition was far more complicated. Near the boundary, solar and interstellar magnetic fields appeared to interact through magnetic reconnection, a process in which field lines rearrange themselves and release energy. The solar system was not magnetically isolated from the galaxy. The two environments were connected. Voyager also detected extremely energetic particles near the heliopause, creating conditions far more violent than the gentle transition scientists had expected. Although the plasma was too thin to burn a spacecraft like ordinary fire, the particles carried enormous energy. This frontier behaved less like a quiet border and more like a collision zone. That matters because the heliosphere helps protect Earth from high-energy cosmic radiation traveling through the galaxy. Voyager has not shown that this shield is failing. It has shown that scientists do not yet fully understand the forces acting upon it. The sun is moving through an interstellar environment that changes over time. As the pressure and density outside the heliosphere vary, the protective bubble surrounding the planets may also expand, contract, or change shape. Voyager's impossible discovery was therefore not only about distant space. It was about the invisible system protecting life on Earth. In late 2023, Voyager 1 suddenly stopped transmitting readable scientific information. NASA continued receiving a signal, but the data inside it had become meaningless. The spacecraft was still alive. Its voice had simply become impossible to understand. Engineers eventually traced the problem to a damaged section of memory inside the flight data system. A small chip had deteriorated after decades of radiation exposure and continuous operation. The defective component could not be replaced. Voyager was more than 15 billion miles away. A command required approximately 22 hours to reach it, and the response needed another 22 hours to return. Every diagnostic attempt consumed nearly 2 days. NASA engineers developed a solution that sounded almost impossible. They divided the damaged software into smaller sections, relocated those pieces into different functioning areas of Voyager's memory, and rewrote the spacecraft's instructions so the separated code could operate together. In 2024, readable data returned. Voyager began speaking clearly again, but its remaining time is limited.